Okay, so you should have the sample project, which you're not going to write on. You're going to return at the end because other people are going to use it. And then this, which you are going to write on. So this is your sample project, and basically I'm going to do the first 3 rows, and you're going to see, and then you'll do the last 3 rows just based on what's here, and then that way you can get a little bit of practice doing the project, and also, of course, getting the practice finding equations of lines. So I'm going to start with line 1. Okay, and I need 2 points in the line, so I'm going to count over 1, 2, 3, 4, 5, 6. Okay, so 6, and then up 1, 2, 7. And then I can see like another point on the line, right? Like I don't need to count up again. I know it's going to be 7 again because it's all the same height. But like another point would be like 8, 7. Or I could choose 9, 7 or 10, 7, right? It doesn't matter. So I'll choose 10, 7. Okay. Now, it says slope. It says I must show my work change in y over change in x for at least 6 lines, but I can count rise or run on the graph for the others. So here's the thing. I look at this one, and I know from slope dude, right? Remember slope dude? That this is 0 fun. And so the slope, it's just 0. The slope is just 0. I don't have to count the change in y over change in x. I could, look, like, so one option is just to write 0. Now, in order, you have to show it for at least 6, so it depends on your other lines. So one option for this is I could just use what I know about slopes to just write 0. And that's fine. Okay, for 6 of them, you can just write the slope. You can just use the graph to look and see what the slope is. Now the other option is you could do this, right? And this would be 6, 7, 10, 7, right? This would be plus 4. This would be plus 0. And then I would end up with y over x, which is, right, change in y over change in x, 0 over 4, which is equal to 0. Okay, so those are, like, both of these options are totally fine. You could have just written 0 and boxed it. That's okay. Okay, now you got to do all this work for at least 6. So it just depends on your other lines. Y-intercept. So here, now the y-intercept, look, it doesn't cross the y-axis, right? But here's the thing, is look, if I just look, and I can even just use my pencil, where would it cross the y-axis? Well, here's the y-axis, I'm not sure you can see it. Here's the y-axis. Where would it cross the y-axis? It would cross right here, right? And I'm writing just so you could see it. Please don't write on yours. So that point is 1, 2, 3, 4, 6, 7, right? It's at 0, 7. So you can just write, you can write 0, 7, or just 7. It's fine. Okay? So that's the y-intercept. I don't need to show work for this one, right? Like this says any line does not cross the y-axis, but this is a special case where like it's clearly going to cross the y-axis, okay? Because it's just flat. If I wanted to show work, I could, and it would be like plugging in, right, y equals mx plus b, and then plugging in one of the points, and then plug in 0 for slope. I could do that, okay? But in this case, this is a line where I would just look, and I would just put 7, and I'll be done. So then the equation is y equals mx plus b, so then y equals, but the slope is 0 plus 7, and then this, actually 0 times x is just 0, right? So this is just y equals 7. Okay, that's my equation, which makes sense because remember, when lines are horizontal, it's always y equals a number. When lines are vertical, it's always going to be x equals a number. Okay, so that's line number 1. So let's do a different kind of line, number 2. And what I'm gonna do is I'm gonna fold my paper so that you can see everything on video. You don't need to do this, but this way, like, we can look at line number 2 and then this at the same time. So first I need 2 points on the line, so just find 2 points where it hits, like here's 1, so that's 1, 2, 3, 1, 2, 3, that's 3, 3. And here's another over here, so that's -1, and then -1, 5. Okay, so I need my slope. Remember, I can count, right? One option is I can just count rise over run, so I could like count rise and run, that's fine, or I can do the work. Because I have to show it for 6, I'm just going to do the work for this one. So this is 3, 3, it's -1, 5, 3 down to -1, and you can use your number line on your notebook. 3 down to negative 1 is negative 4. 3 up to 5 is 2. So change in y over change in x becomes 2 over negative 4. I can divide both of these by 2. I get 1/2. And a positive divided by negative is a negative. So I get negative 1/2. So my slope is negative 1/2. And remember, I could have counted rise over run 2, and I would have gotten the same. I would have gotten like down to right 4, and I would have gotten negative 2 over 4, which is also negative 1/2. So same thing. Now the y-intercept. In this case, this line hits the y-intercept, so I don't need to do any extra work. Now, I notice though it doesn't hit the y-intercept at a whole number. It hits the y-intercept 1, 2, 3, 4. This is 4, and this is 5. I notice it hits like halfway between, so the y-intercept is 4.5. Okay. So just read carefully, and if you find that the line hits like up here or up here, you can just estimate it. It's okay. It doesn't have to be like exact, or you can redraw the line if you feel uncomfortable with that. So here's my equation. Y equals the slope times x plus the y-intercept. And that's it. Here's line 3. Let me fold my paper again so we can see it. And line 3 is down here in quadrant 4. Let's see, can we see everything? Okay, let me adjust so you can see. So here's line 3. I'm going to find 2 points in the line. I see this point. So that's 1, 2, 3, 4, 5, down 2. So that's 5, negative 2. And I see this point. So that is 1, 2, 3, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 3, negative 10. So for the slope of this one, I can count rise over run, or I can do the slope. I'm going to count rise over run for this one, right? So I could also do, right, I could do the xy table, and I could find the slope. I have to do it for at least 6. But on this one, I'm just going to count the rise and the run. Just, right, like, do something different each time. So the rise and the run are here. So, and again, please don't write on yours, right? I'm just writing it so you can see it. So this is 1, 2 is the run. And then 1, 2, 3, 4, 5, 6, 7, 8 is the rise. So rise over run. And just write, like if you do rise over run, just write rise over run so I know how you did it. Is 8 over 2. And that simplifies. 8 divided by 2 is 4. Okay, so the slope here is 4. Then the y-intercept. Now, the y-intercept becomes a little bit more complicated because this line does not hit the y-axis. And in fact, if I see if I can extend it with my pencil, it doesn't even hit the y-axis anywhere on the graph. So I really can't see where it's going to hit the y-axis. And so this is a case where I really just have to do the math and figure it out. So that's no problem because I have the slope, which is 4. Okay, and I have points. So I have like an x and a y, right? So when I have y equals mx plus b, I'm going to have to squeeze it in a little bit. So m is 4. And then I'm just going to use this first point, 5 to negative 2. So x is 5, and y is negative 2, and this plus b. And I'm going to make a prediction really quick. If I look and see where this line's going, right, where is it going to hit the y-axis? It's like, well, way below the graph. Like, not way, way below, but like below the graph. So it's going to be the y-intercept when I figured out, it should be negative. It should be like a pretty big negative number, right? Because I'm already down here at like negative 10, so it's got to be like negative more than 10. So let's just make sure I get an answer that makes sense. 4 times 5 is 20. And I'm going to subtract 20 from both sides. Negative 2 minus 20, so that's 2 negatives and 20 negatives. It's a total of 22 negatives. So that answer makes sense, right? This is like it's going to hit the y-axis way below the graph at negative 22. And so then I have my y-intercept and my slope. So y equals 4x minus 22. And now it's your turn. So you're going to do lines 4, 5, and 6 just as practice, and then you're going to get it checked. And so that way when you go to do your own project, you're not confused. Okay? I'm just going to start you off with number 4 because So number 1 was a horizontal line, which has a slope of 0, right? So if you remember, number 1 was here. It was horizontal, goes left to right, and has a slope of 0. The thing is that this line is vertical. So if you remember slope dude, vertical lines, they have a slope of undefined. Right? So this is gonna change your work a little bit, right? So let's just really quick, let's find 2 points and then I'll start you off, but I'm gonna leave you to figure out the end result here. So the 2 points are, here's my origin, 1, 2, 3, 4, 5. So that's -5. 1, 2, 3, 4, -4. And then the other point is going to be -5 and then something else. I don't know, -7, right? There. So it's undefined, right, the slope. And if I look, right, this line, it's going to go up and down forever. And it's actually never going to hit the y-axis. So there is no y-intercept, okay? But I'm going to leave it to you to figure out the equation. And what the hint I'm going to give you is to look at the points. You know that the equation is either going to be y equals something or x equals something. So notice the points and notice, well, which coordinate is the same in both? Which coordinate does it have to be, right? Like, for example, I can't make the equation y equals -4 because look, here y doesn't equal -4. Okay, so you figure out what the equation is and then also do line 5, which is most similar. Line 5 has some similarities to line 2, so you can reference that as an example. And you're also going to do line 6, which has some similarities to line 3, so you can reference that as an example. So try those two and get them checked. That way you know that you're understanding what the project requirements are.